Good morning, everyone. Welcome to this EDA Technologies webinar series. Today we are discussing flex rigid PCB design in Altium Designer, and I'm hoping that you will leave this lesson more informed and able to do in a PCB design of flex rigids much better. So thanks for joining. Thanks for your support. And I think the reason why most of us are joining a webinar like this is that we're interested in getting things right the first time. And I think in this age that we're living in right now, especially with COVID, we can't afford to delay in getting our product to market. We can't afford additional expenses in getting product to market because of many revisions and design iterations. So it's quite important to focus on knowledge so that we can do things better and more efficiently. And that's what we aim to share with you today from EDA Technologies. And hopefully you can prevent some embarrassing mistakes going forward. So just a brief intro. Most of you know us. EDA, we've been around since 1997. Yes, I know, it's been ages. I've lost a lot of hair, grown a belly, and inherited 2 grandchildren. But besides that, we still eat, drink, sleep PCBs. Happy to service you and to provide you PCB related services. So as you know, we sell Altium Designer, and many of you are Altium users. And please continue to contact Luke or EDA for any Altium related needs, and we'll be happy to assist you. Also, when it comes to PCB design, some companies request our services because they don't have the skills in-house, or perhaps they don't have resources at the time. So we've got specialists in-house that can handle high-speed designs, designs regarding thermal, with thermal issues, flex rigid, and very sophisticated PCBs. So if you need help, not only in design, but maybe in DFM or anything related, please remember that we are here to help you. PCB manufacturing, we'll talk about a little bit about that later. And then of course we offer a number of courses and seminars. We've created a new platform now which will be launched very soon, and this platform is going to bring the experts from around the world to you. Due to COVID, it's changed the way we do things, so we've got quite a number of excellent topics coming your way from experts around the world. EDA has created a new platform for this, so we will share more of this with you soon. So please visit our website, edatech.co.za, and we've accumulated a lot of online resources for you, design guides, useful charts, and so on to assist you with your PCB design. So please visit our website often, as we upload new content all the time. Also, if you need support when it comes to PCBs, we've got in-house experience with PCB stack-ups. We can do very, very complex PCB stack-ups with blind and buried vias and so on, impedance controlled, backplanes. So if you need stack-ups, it's not always easy to know what to use in a stack-up, but that's where we can offer lots of our experience with you, especially material choices. Nowadays, you know, many manufacturers are cutting corners due to cost of PCBs and competition. Material choice is becoming extremely critical. It's like many people will, for instance, only use certain brands of tires on their car for reliability, high speed, performance, and so on. The same goes with PCB materials. You can't just use any material anymore. It's highly risky. So that's where we can bring our expertise and share this with you. So if you need any of these, please contact us and we'll be happy to assist. To give you one example, we did an exercise for a company on panelization. We repanelized their board, shaved off a millimeter here or there to optimize the panel utilization, and we saved the customer 36% on the total quote value. So that's something that we can offer you as well. We represent NCAB Group, stands for Nordic Circuits. Some of you may be familiar with Nordic Circuits, and Nordic Circuits is the world's largest PCB supplier. We've been representing them for over 10 years, and we've got a nice footprint in the country. So if you need any PCBs, high tech, high volume, no matter what it is, we can really assist you. Even if you go to NCAB's website, you'll find a lot of useful resources. So a good reputation, extremely good quality, and high reliability. So please contact us for any of your PCB needs. So in-house, to service you, we've got Veronica, who handles customer care and license sales, Roxanne as well, customer care, renewals and training, and Luke is our in-house resident expert on Altium. He'll be delivering the remainder of this webinar today. So we at your beckoning call. You can contact any of these individuals through Skype or mobile or email. So let's move on to the topic for the day, flex rigid PCBs. And I'm sure that you will agree with me that it's becoming more popular with cell phones folding and wearable technologies on the rise. Flexible PCBs are becoming much more common. When I started doing PCBs as we came out of Noah's Ark, it was really very, very expensive. Not many companies could do it successfully and so on. But now it's commonplace, because if you look at the number of products that are using flex rigid today, lots. Wearable technologies, high-tech products, they all of them. If you open up a hard disk, you'll find that there's flex rigid cables in it, cameras and so on. So because of that, it's become much more cost effective, and many products are using it due to miniaturization and these sort of needs. The advantages of flex rigid, there's quite a number of advantages. The one advantage is you don't need connectors and cables. And if you have lots of experience with electronic assemblies, you will know that that is a big, massive pain, connectors and cables. So the fact that you're eliminating that is a big plus. Reducing assembly costs, because you don't have to do harnesses and connectors and SMT assembly and so on. So that is also an advantage. And also the whole assembly can be tested in one stage. You don't need a jig for every PCB. You test the whole lot in one go. So if you look at that, you know, the advantages outweigh the cost of the flex rigid in many cases. Reliability is much better, because you don't get cables and connectors coming loose. And also, you know, the risk of assembling components wrong or crimping a connector wrong is eliminated. It can withstand much better vibration. So if you're doing avionics products, this is a much better choice. And then also the packaging, you know, you're using a lot less space on the board. You don't need connectors and bulky board-to-board connectors. So there's lots of advantages to flex rigid PCBs. Disadvantage is the tooling cost is usually much higher, because, you know, to keep the thing together and to align it and to make sure that the expansion in the XY direction is within tolerances, there's a lot more to be done in the jig. So that's a little bit more expensive. The material is more expensive than traditional FR4, but like I said, because we're making so many boards now and flex rigid, you know, the cost is definitely coming down. And then the lead time, it's not conventional material, so it's slightly longer, but depends on your material choice again. If you consult with us and we can help you with the material choice, then we could limit that lead time to purchase the material. One of the biggest drawbacks on flex rigid is the moisture absorption. So it absorbs moisture at a much higher rate than traditional FR4. So you may need to take extra precautions, or make sure the whole entire unit is fully encapsulated. But that's one of the drawbacks. However, there have been great material improvements over the years, so we can also advise you on materials from DuPont, as well as materials from Panasonic that are very, very good. And of course, you know, it's sensitive to scratching, so handling is very important, and you need to store it under the right conditions, mainly because of moisture absorption. That's the main reason. But generally, the advantages far outweigh the disadvantages, and we're seeing a much bigger uptake on flex rigid design and manufacturing coming through to EDA as well. Material choice, like I said earlier, is very, very important. So we can advise you here as well on what material to use for, depending on the application you have. So if you're going to have lots of bends, like a printer cartridge that moves back and forth all the time, then you're going to need a specific polyimide that can take those bends, and also it can take a lot more cycles. Polyester is more for harder wearing, robust environments where you're going to have maybe 5 or 10 bends in the lifetime of the product. Then that could work, and it's normally cheaper. So there's various choices that are out there. We're just mentioning this so that you are aware. It's, you need to be very clear depending on the application and how you want the product to be used. So there's a number of rules that apply, and we can assist you with this as well. We've done a separate seminar on this before, but certain rules when it comes to PCB design, because it's copper that's bending quite a number of times, and you can have metal fatigue, there's certain rules that have to apply. So one has to take that into account. Some things like annular rings, how close to the edge can it be, and so on. So there are special rules. We're not covering it in this webinar because we're focusing on how to do flex rigids in Altium Designer. But we thought we'll include these few slides just to let you know that many companies are going this route. It's becoming more cost effective, but it's important not to just look at the cost of the flex rigid on its own. If you compare a flex rigid to a rigid board with connectors and cables, flex rigid will come out more expensive. However, one needs to look at the total cost of the product, not just the flex rigid cost. If we look at the total cost, the cost of assembly, reliability, space saving, all of that, then the savings in many cases outweigh the costs of the individual flex rigid board. So please contact us at any time if you have any questions, and we'll be glad to assist you. We've done many designs of this nature over the last few decades, and we'll be more than happy to assist you to get it done right the first time. So now we're going to hand over to Luke. So I've been sharing some information with you. In case you haven't heard, my name is Nechan Naicker, and I'm very glad that you've joined us, and I look forward to more interaction. But right now I'm going to hand over to Luke, and Luke is going to take us into Altium Designer and how to do flex rigid designs in Altium Designer. Thank you very much.
Thank you very much, Nechan. Glad to be here with everyone. So as you can see on screen, the latest version of Altium is 21.1.11. It's the version that I'm going to be showing everything in the live demo just now. So be sure to update. If you're not sure how to update to the latest version, feel free to drop me an email or reach out to me on Skype or WhatsApp. I'll be more than happy to help you with your updates. So next thing that we're going to do is I'm going to do a live demonstration on how to set up flex rigid designs in Altium Designer 21.1, and that's going to cover everything from stack up to defining the layer regions and even bend lines. So I'm going to switch over to Altium now, and let's have a look at that. Alright, just a second. Alright, so here we go. I'm going to be working with a modified version of Altium's Bluetooth Sentinel PCB example. This is installed with Altium Designer. So if you guys ever want to experiment with a flex rigid board that's not your own design, have a look at this project. It is installed with Altium, and it will be in your example projects. So here you can see I've got my document and everything. And if I go over to 3D view, you can see it's just solid FR4 at the moment, which is as we'd expect from a non-flex rigid board. So the first thing that we'd need to do is you'd obviously have to define your exact board regions that or board shape that you want. As you can see, I've already got this here. Then what we need to do is we need to go to the Stack Up Manager. To do so, we can go to Design, and then we go down to here, Layer Stack Manager. Give this a second to open. So here you go. You can see I've currently got it set as a generic 4-layer PCB. 4 signal layers. We've got 3 dielectric layers in between. And there we go. So in order to start with Flex Rigid Design in Altium Design 21, you first need to go over here to the Features button, and you click the little drop down, and then you'll see here that there's a bunch of different features here. We've got printed electronics. That's for 3D printing circuits. We're not going to be covering that in this webinar today. Then we've got rigid flex, which is what we are going to be focusing on, and then backdrawls for defining backdraw information. For now, we're just going to select rigid flex. Nothing much seems to have changed on the screen, but you'll notice here is we've now got the option of selecting multiple layer stacks. So what we're going to do is we're going to add a new layer stack. So by clicking the plus, and you'll see now that we've got one called stack 1. This is going to be our flex stack. So what we do is we click on properties, and then we define it as our flex. So we give it the name flex, and then we choose to define it as flex by clicking is flex. This tells Altium that this is a flex layer. So next thing that we need to do is we need to define our layer stack correctly for flex rigid. So in this case, I'm going to be changing dielectric 1, which is this middle dielectric here, to our flex material. So I've already got one saved in my materials library, which is a very useful feature in Altium, is you can add materials for various different finishes, your different conductive foils, cores, everything that's needed to generate a stack up, you can generate in the flex layer Altium material library. So if I scroll down here, you can see I've got a Panasonic polyamide prepreg already defined. So I'm going to be using that. It's fairly easy to add new materials to this library. You just click on new, and you enter in the manufacturer's name, all the various things like dielectric constant, dissipation factor, glass transition temperatures, the thickness of the material, and so on and so forth. So I'm going to cancel that. I'm not going to add anything new. So if I want to use this material in my design, it's as simple as going over to this material here, changing it to prepreg there, and then selecting it from the list here. So as soon as I select it, you'll see that the thickness has already changed. Everything has changed as it needs to be. So for these, I'm going to change these to core. Okay, so I've got my stack symmetry on, so it's already set to core. So you'll see that I did this under the flex section, but if I go back to board layer stack, it's exactly the same. So in the flex section, I'm not going to be using a lot of these layers here. So in this case, I turn off what I don't need. And as you can see, because I've got my stack symmetry turned on, it will automatically make my stack symmetrical. So in this case, I'm just going to be using the 2 middle layers and the central dielectric. So what I can do then is I can save this. So I just click the save icon, and then I can close it. And now on my PCB, it is now set up as a flex rigid. You can even see my layer stack table has changed already. So, but as you can see on the board map, nothing has changed because I haven't defined any regions yet. So to define my board regions, what I do is on my keyboard, on the number row above where all the letters are, I press 1, and that goes into board planning view. I believe you can do that from the view option as well by selecting board planning mode. Alright, so now as you can see, there's my one region that I've got on the board, and it's covering the entire board. Now, a difference in Altium 21.1 to every other version of Altium that's come before is board regions are now defined as a kind of polygon, which means that you can get more intricate shapes rather than the very simplistic straight line cuts that you could in previous versions of Altium. So let's go about setting up our flex region. So our flex region is going to be this strip that goes across here, and it's going to extend up until these little straight points inside the circular sections of here. So to do this, we're going to say design slice board region. And now you'll see I've got my little cursor here. So what I can do is, let me just make sure that my snapping is on by going to properties. And I say snapping on all layers. And then I say design slice board region. And you'll see there that it snaps to that corner point. So I can click and then just drag straight across to there and right click. And okay, why is it not slicing it? Design slice board region. So let's just slice it like this. Okay, there we go. So confirm, split one polygon into two polygons. So I click on yes. And now you can see I have now two separate polygons. Okay. So now we're going to separate the bottom layers, the bottom circle from the strip. And I'm going to just show you a quick example of the unique shapes that you can put into the new flex definition. So what we do is we say design slice board region, and then I select from there. And like any polygon placement in Altium Designer, if you press Shift and Space, you can change the corner style. So there we've got any angle, there we've got a 45 degree, there we've got an arced 45 degree. So let's just lay out a quick and simple design like that. Okay, so it's not quite done. So no, didn't quite place it right. So split board region from there. Alright, so if I do it like that, it's not wanting to behave with me right now. Design slice board region. Sorry about this, folks. It's a little bit finicky sometimes because this feature is still very new to Altium, so there is a few little issues that they need to finish working out. Come on. I got it working earlier. There we go. So if I do it like that, now you can see there's a polygon region or a board region that is now got a arced chunk out of it. This allows you, say for instance, to if you've got a strip like this and you want a stiffened piece at the end here that's got a bit of like a cutout to it, or if it must come to a rounded piece on this side, it allows you to say, okay, well, this is going to be how it is, and it doesn't require you to do any particularly fancy board shapes. So that's how it's intended to be used in this case, is to build like a cutout like there of solid. So I'm going to just undo, and I'm just going to place a straight cut across there again. So what I do is I go like so, and of course it doesn't want to play nice with me. Okay, so I place it there. Okay, there we go. So now we've got our bottom solid layer or rigid board, our top rigid board, and our center rigid board. Okay, now to change this to a flex, what you can do is you just double click on it and it'll bring up the board region dialog. where here you can just select which layer stack that you want to use. In this case, it's the one I labeled flex. You can even change its color here, so let's change it to a light blue so it's quick and easy to tell the difference. And we'll give this as flex region. And we click on OK. And here you can tell. So this allows you to change the color of the polygon for each bordered region so that at a very quick glance you can tell which is which. So in this case here you can see I've set it so that blue is flex and green is rigid, which makes a lot of sense in this case. Another thing that you want to do is on one of the regions, I believe it is, I can't remember where they put the button now, but you could set it as the 3D. In previous versions of Altium, you could set a region as the 3D anchor point, and it would fold. When you fold the board, it would set it so that that region doesn't move. I'm not sure where they've put it to now. I believe it's the priority 0. Sorry, just a second here. Okay, I think it might actually just be that lock icon there that locks it in place, but we'll see that now when we do the fold test. So next thing that we want to do is we want to add our various bending lines to the flex rigid so that we can visualize folding our board into a nice shape. So if I go over to the PCB panel and I go to layer stack regions here at the top, you can see that we've got our two layer stack regions, board layer stack, and there's 4 layers in that, and flex, which has got 2 layers. So if I click into flex, you'll see now that it's going to, and I click on flex region, you can see there that it highlights it, and because I've got my masking on, it masked it there. I'll just clear that by going like that. Okay, so in order to place bending lines, what we'll do is we'll go to place, and we say define bending line. So this is again placed like you can see here. You just place it straight down like so, and like so. And you'll see there that they appear here. So for these bending lines, I know that their angle must be -145 degrees, and we're going to be using a radius of 13.435 millimeters. And so there you can see the affected area of the flex that will be bent when we do our folds. So I'll set up the second one now to also -145 and a radius of 13.435. Alright, so you'll see here now that there's a sequence starting at 0, because tables start at 0 in Altium. So when we do the fold, the sequence dictates in which order the folds will happen. So I'll be changing these to a different sequence point in a moment, but let me first add all our other little lines here just to get everything nicer and ready. So we define another bending line, and in this case we're going to go from here to here. You can see here that I've got lines on a mechanical layer here, where I'm defining where my bending lines are going to go. This is useful in this case just so that we can make sure that everything goes where it needs to be. Obviously in your design, it doesn't impact manufacture where you decide to define your bending lines. This is just more so that you can visualize and make sure everything fits together. So if I go to here, then place another defined bending line and place these two, and these are going to be -90 degrees because we're wanting to fold away from the camera as we're looking at it now, and that one will go to -90 as well. You can also see which bending line you've got selected. When you click on it, it will highlight it. So in this case, that's that one, and there's this one. And when I click on this one, you can see here this bending line is highlighted. So this helps to know which bending line you're selecting so that you can get your order correct. Alright, so let's just place the last two bending lines. It's going to be from here through to here, and from here through to here. And these two are going to be negative 25 degrees with a default radius. And that one's going to be also negative 25 degrees. Alright, so now you can see that everything is got the same sequence of 0, which if we were to fold the board in 3D view, everything would fold all together, which can be a little bit confusing. So what we're going to do is we're going to select this bending line here. So that's this one. And we're going to have it with the fold index of 0. Okay. Then our two 25-degree lines, we're going to give this the next fold index. So we're going to go 1 and 1. So these two will be the next to fold a little bit. Then fold number 3 is going to be our second 90 degree. So that's going to be this one. That'll be fold number 3. And fold number 2 will be these. I know I did it in a bit of a weird order, but I am working off of a little piece of paper that I've got with me that's got all the numbers marked down for me, just so that I didn't get anything wrong. So now that we've got all of that in place, we can go over to 2D view, and as you can see, our differences in the board region are demarcated by these little hashed lines, so that you can tell when you're crossing over into various different things. Also, if I try and take something on a layer that's not on the flex area, so if I say place track from top layer, you'll notice that I cannot go into the flex region. But if, say for instance, I were to swap to mid layer 2, which is on the flex, and I say place track, it goes in perfectly fine. So that does help with making sure that you don't accidentally put something where it physically cannot go. Altium's pretty smart like that. So now, if I go over into 3D view, and I view our board, you can see here that it is there. We've still got the black covering over because I do have in my layer stack, I did put the solder resist on the flex area. So if I go here and I just disable that quickly, so top solder resist and bottom solder resist is off. So, and then I save, and I go back to our PCB, and I go into 3D view. You can now see that the solder resist is no longer applied there. So, how do I get my PCB to now fold into the shape that I want it to be? Well, that's pretty simple. You can see here under the bending lines, there will be a state known as fold state. If I drag this along, you can see how the entire unit folds up. And there you go. So that's how you can see how your PCB folds together. So let's just drag that back. And there you go. So what I'm going to do is I'm going to also now quickly show you here. Now you can see on the layer stack up, we've got our board layer stack, which you can see is defined by the top right to bottom left hatching, which is indicating on those two circle points, and then the top left to bottom right hatching indicates what's our flex area. This is also very useful for when you send it to your manufacturer, because then they can see in the Gerber files, oh, this is supposed to be flexed. Then there's no worrisome queries where they have to now try and study or question you about your design. It's like, okay, what's supposed to be flexed, what's not. This just makes it easy for them to see. So what I'm going to do is I'm just going to quickly open another document here, that I've got, which has got the board fully populated. So just a second. If I just do this, and there we go, this is the board fully populated as is from the sample project as Altium gives it to you. And if I go into 3D view here, you can see here that they've got some LEDs and resistors that go onto the flex area and all their chips, as well as a little coin battery cell holder there. Now when I fold this, you'll notice that their fold sequence is a little bit different to mine because I did some modification. So if I fold, you can see how everything folds together nicely there. And this allows you to be able to tell, is everything going to fit? You can activate DRC for design rule checking so that you can tell if there's going to be collisions. It will actually highlight the components that collide when you fold it up in 3D view. Okay, and something that's really useful, that if you do a lot of collaboration with your MCAD guys, like you've designed your board and now you want to make sure, does everything actually fit into the enclosure? What you can do is when you go to File, you can say Export and then Step 3D. So we're going to be exporting this step as is. And what you can do is you can export the board already folded, and you can say at what percentage do you want it folded. So I'm going to just say I want a 100% folded board, and everything else we can export everything as is. We click on OK, and there we go. We've exported a 3D step model now of our folded board, which now if I go into Mechanical 13, I say place body. Let's just quickly place the step model into this design so I can show you that it's exported as folded. So I go here. Okay, let's just quickly navigating over to. So there's the step model. I click on open. And you can see there that it's a relatively small square that matches the outlines of one of those half circles. So you can see it's a small model, and if I go into 3D view, you can see there's our exported model floating there. Now it doesn't look quite right because again it's a step model of a board, so the colors aren't going to be 100%, but for sharing with the MCAD guys and making sure that everything fits into the enclosure properly, this is more than sufficient. Now this export can also be done from the outjob folder, which you can, which if I open it here, and I go to, let's just assembly outjob, what I can do is on the export outputs, here I go, export step, PCB, and what I can do is there I can just choose to export the folded board. Now if you've also got a 3D mouse, you can create like a little pan fly through of the whole thing, and you can actually release a 3D video. If I check it here, it would be, it's under one of these options. I can't exactly remember where it is. I've never used it. Post-process outputs, I believe. No. So it's one of these. It'll be an option here. I'm not sure which option it is exactly again, but you can use a 3D mouse to do a fly-through of the whole process of it folding up, and you can give that to the MCAD guys as well, or whoever's going to be assembling your board into the enclosure, so that they know the process of how it goes together. So that's how to do setting up rigid flex designs in Altium and getting some decent outputs from it. If you guys have any questions, feel free to send me an email. For some reason, my Zoom isn't working right and I can't enable the chat panel. I'd love to be able to do so to answer your questions right now. But if you guys do have any queries, feel free to reach out to me on my email. You guys saw it all earlier. I'll bring up the slide again in just a second. Let me just bring up my email again. There you go. feel free to reach out to me on my email, my Skype, or send me a WhatsApp. I'll be more than happy to help you guys out with any queries you got with Flex Rigid Design in Altium, or setting it up and getting it working. And also, if you guys want any of the white papers from Altium on Rigid Flex PCBs, feel free to send me a message as well. I'll be more than happy to help you get hold of these. These are very good resources for doing Flex Rigid PCB design. Again, you can contact me for any of these documents from NCAB as well. This is recommended stack-ups, recommended assembly instructions, all these sorts of things. As well as, if you guys need any additional Altium licenses, or if your subscription is expiring, feel free to reach out to me, either myself, Veronica, or Roxanne. Will be more than happy to help you. If you guys need PCBs manufactured, feel free to reach out to me. I will be more than happy to get you guys a quote. Stack-ups and advanced designs, you can reach out to me as well. I'll get stack-ups from NCAB and other factories if required. And if you've got any other design questions and such, again, feel free to reach out to us. We'll be more than happy to assist you. It's what EDA is here for. We're here to help you guys release the best product you possibly can. Again, thank you very much for joining into our webinar, and I hope to see you guys in the next one. I'm going to be playing a bit of a musical interlude, and that's the end of the webinar for now. I'll see you guys in the next one. Enjoy the rest of your day.